February. Start with your February. Let it be a blessing to you. Okay. So, okay, we will start with your matrices. So, you should have known what is your matrices. Your matrices is nothing but a rectangular arrangement of rows and columns. And then we went into the types of matrices. You should know what is a row matrix, what is a column matrix, what is a square matrix. You have to know what is the identity matrix. Okay, for everything you should know an example. Okay, only one example is enough. You keep just keep it in mind. So for a diagonal matrix means what it has to be. It has to be a square matrix where in the diagonal alone you will be having elements. All other terms except the leading diagonal, it will be 0. So that will be your diagonal matrix. Then what is your square matrix? You have to know. Identity matrix. For a 2 cross 2 matrix means what is your identity matrix? 3 cross 3 means what is your identity matrix? And then we went into your Cayley-Hamilton theorem. Definitely you have to know the statement. Now, Cayley-Hamilton theorem statement is every square matrix satisfies its own characteristic equation. That sentence must not go wrong anywhere. Okay, it is a definite 2 marks question. So Cayley-Hamilton theorem means every square matrix satisfies its own characteristic equation. Okay, and then you'll have to know your characteristic equation. How you have to find out your characteristic equation? The general format of your characteristic equation is, what is it? It is determinant of A minus lambda I, okay, equal to 0. This is your general format of your characteristic equation. But when you take it for a 2 cross 2 matrix, your formula will become lambda square minus S1 lambda plus S2 equal to 0. Okay, where your S1 is equal to sum of the main diagonal elements. S2 is your determinant of A. This is for a 2 cross 2 matrix. For a 3 cross 3 matrix, lambda cube, you can also tell, okay, so that you will remember. So lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. Okay, this is your characteristic equation for a 3 cross 3 matrix. So here your S1 is the sum of the main diagonal elements. S2 is your sum of the minus of the main diagonal elements. And S3 is your determinant of A. Okay, so after finding out your characteristic equation, for verifying your Cayley-Hamilton theorem, instead of this lambda, you will substitute A. A is your given matrix. Okay, so you will substitute your given matrix and make it equal to 0. You have to verify it. After verifying it, what and all you can find with that? You can find your inverse and your higher powers of A. Okay, higher powers of A means like A power 4, A5, A power 5, A power 6, and so on, whatever it is. So you will prove it, isn't it? So with that equation, if at all it is A power 4, you will just multiply it into A. Okay, if it is A power 5, you will multiply into A square, that equation. Okay, you will multiply it into A square. And similarly, and so on. You will multiply and you can get. So the uses of this Cayley-Hamilton theorem is, one, you can find out your inverse. How do you find out your inverse? You will multiply that equation into A inverse and get your A inverse. Okay, and your powers of A, how do you find out? Whatever power you want to do, you will multiply and get it. Okay, these are the uses of the Cayley-Hamilton theorem. Now we will do one more problem related with your Cayley-Hamilton theorem, and with that I will stop with your Cayley-Hamilton theorem, and from tomorrow's class we will go on to the next topic. Okay, so write it down. Put today's date. Right, verify Cayley-Hamilton theorem. Verify Cayley-Hamilton for A is equal to 1, 0, 3, 2, 1, minus 1, 1, minus 1, 1. And also find A inverse and A power 4. And find A inverse and A power 4. Okay, find out. First, find out your characteristic equation. It is the 3 cross 3 matrix. It's the 3 cross 3 matrix. First, write the formula for a 3 cross 3 matrix. What is your formula? Tell me. The characteristic equation is, you have to write your formula. Lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. Okay. As soon as you get the question, you will have to write your characteristic equation. Now, what is your S1? S1 is the sum of the main diagonal elements. What is the sum of the main diagonal elements? So this is your given matrix. What is the sum of the main diagonal? I want you to work it out and tell me.
3.
3. So this is your main diagonal element. Okay, 1 plus 1 plus 1. Okay, and then your S2 is your sum of the minus of the main diagonal element. Minus. Okay, you have to take your minus of the main diagonal. So the minor of this 1 will be 1 minus 1 minus 1 1. Okay, always write it and do it, otherwise sometime you will go wrong. Okay, plus minor of this 1 will be 1 3 1 1 plus minor of this will be 1 0 2 1. Okay, so this is the sum of the minus of the main diagonal. Now when you multiply, you'll have 1 minus 1 minus into minus plus, but you've got one minus, so minus plus 1 minus 3 plus 1 minus 0. So you'll have 0 minus 2 and plus 1 is 0 minus 2 and plus 1. So what is your S2? What is your S2 you're getting? Write it here.
Minus 1.
You're getting minus 1. So your S2 is minus 1. Always put a box so that you don't go wrong. So that is your answer. You can just. Your S1 is 3, your S2 is minus 1. Next, you'll have to find out your S3. S3 is nothing but determinant of the given matrix. So find out your determinant of your given matrix. 1, 0, 3, 2, 1, minus 1, 1, minus 1, and 1. Find out your determinant.
Minus 9.
Be 1. How much you're getting? You got the answer. Tell me. What is the answer you're getting? Minus 9.
Minus 9, ma'am.
For everyone, you're getting minus 9. Very good. S3 is minus 9. Check whether you're getting minus 9. You have to do it really very fast, otherwise you won't have time. Okay. Characteristic equation is only 2 marks in your 16 marks question. Okay. So do it really very fast. Your sum, you can do it really very fast. Then your minus, when you're writing this minus, be very careful in taking it from the question. Okay, when you're taking it from the question, don't leave off some value. Okay, be concentrate and write it down. You won't go wrong. Okay, and then you go into your determinant of A. Your determinant of A is very easy if you know the procedure, how you have to find out your determinant. Then write your characteristic equation. Write your characteristic equation. You'll substitute your values of your S1, S2, and your S3 in this formula. So your characteristic equation will become what? Lambda cube minus S1. So
minus
here
3
you've got
lambda square.
very good. 3 lambda square. Then it is plus S2.
Minus A.
But here you've got
minus lambda.
So it will become very good. So it will become minus lambda.
Plus 9.
And then minus x3 minus into minus plus. Very good. So plus 9, which is equal to 0. So that will be your characteristic equation. Okay, be very careful with your negative sign and your positive sign. According to the formula, write it down. Write it quickly. As soon as you find out your characteristic equation, next you'll have to verify your Cayley-Hamilton theorem. To verify your Cayley-Hamilton theorem, instead of this lambda scalar, what you will do? Instead of lambda, you will write a given matrix. Okay. So your characteristic equation is lambda cube minus 3 lambda square minus lambda plus 9 equal to 0. So this is your characteristic equation, which we have found out. The same thing which I have written it down, I have written it on top because I'm going to rub the board. Write it quickly. So to verify your Cayley-Hamilton theorem, right, to prove, what you have to prove? Your a cube minus 3a square minus a plus, if you have got a constant term, you will take it as identity matrix, 9i equal to 0. Okay, this you will have to prove. So that will be your first step. Okay, so to prove this, what you have to do, first you have to find out your a square, then you have to find out your a cube, substitute it and see whether it is equal to 0. And your Cayley-Hamilton theorem, your statement is every square matrix satisfies its own characteristic equation. So it should definitely satisfy. Okay, if it doesn't satisfy, whatever you found out is wrong. Okay, now you're going to find out a square. So first you will find out a square. So that is a dot a. So multiply 1, 0, 3, 2, 1, minus 1, 1, minus 1, 1. When you're writing your values, be very careful. It is 103 to 1 minus 1, 1 minus 1, 1. Again, multiply it with another matrix 103 to 1 minus 1, 1 minus 1, 1. Okay, now you'll have to multiply it. Row and column. Okay, first row, first column. Multiply and tell me the final answer. 1 plus 0 plus 3. Do it stepwise if you don't know to do it directly. Okay. No, no wrong in that. First row, second column. 0 plus 0 minus 3. Then 3, 0 minus 0 plus 3. Okay, that is your first row. Second row and first column. 2 plus 2 minus
Plus
1.
2.
Tell me.
0 plus 1 plus
You're telling me the answer or still? Okay, tell me. 0 plus 1 and plus 1. Very good. Then it is 6, this row and a third column. Minus 1 and minus 1. Third row and first column. So it will be 1 minus 2 plus 1. Then third row and second column 0 minus 1 minus 1. Then it is 3 plus 1 and plus 1. Okay. Then what you have to do, you have to add it or subtract it. Okay, so it will be 4 minus 3, 6, 3, 2, 4, 0, minus 2, 4, 5, 5. See whether you're getting this a square. See, are you getting this a square?
yes, ma'am.
3. Yes, very good. So next you find out what is your a cube. Now we have found out your a square. Next, you have to find out your A cube. A cube, how you find out? A square into A. Okay. Find out. I will write this A square that side so that I will have this value, or I'll write it here. You can write your value for your A square. So your A square is 4 minus 3, 6, 3, 2, 4, 0, minus 2, and 5. Okay. Similarly, after this, you can find out your A cube. This I'm just keeping it this side so that I will rub this side. Okay. Next, you have to find out your A cube. A cube is A square into A. Have you all finished writing? Just write quickly. If you've got any doubts, ask me. Cayley Hamilton theorem is very, very important. Cayley Hamilton theorem, I'm telling it any number of times. Okay. So if you've got any doubts, please ask me. Then now you found out your A square. I will rub it. Yes.
Yes, ma'am.
Okay. So next we will find out your A cube. Okay. So your A cube you're gonna find out. So I'm gonna substitute your A square value here, which is 4 minus 3, 6, and 3, 2, 4, 0, minus 2, and 5. I will give you time, you yourself do it. You'll do it by yourself. Do the calculation and tell me the final answer. Don't see the board, you do it by yourself. You can check it. Tell me the final answer you're getting.
4 minus 9, 21.
4 minus 21.
21. Level minus 2, level
Yeah.
1 minus 7, 16. 1 minus 7, 10.
10 now. This last one,
7,
your
ma'am.
value? 7. What you said me 10. Check whether you're getting this 4 minus 9, 21, 11 minus 2, 11, 1 minus 7 and 7. Superb. So that is your AQ. Okay. Don't go wrong in anywhere. Okay. Addition, subtraction and all you have to have. If you are not able to do this addition and subtraction, use your calculator. Better use your calculator if you think that you will go wrong when your subtraction and your addition. Okay, this negative sign and all you must not leave. Okay? So this is your A cube. Now we have found out your A square, we have found out your A cube. Now we can substitute it in this equation and check whether it is equal to 0. So I will write this A cube value also separately here so that I can rub it. So 4 minus 9, 21, 11 minus 2 and 11. Got 1 minus 7, 7. Okay, that is your A cube. Have you all finished writing your A cube? Do it quickly. Okay, finish with this. Next, what you're going to do, you're going to find out this equation. Okay, So if you want, you can find out your minus 3a square. Otherwise, you can directly substitute also. What do you want to do? You will find out 3a square. So your 3a square is nothing but you have to multiply your a square into 3. So your a square is this term. So 3 into 4 will become 12. Then minus 9, 18, 9, 6, 12, 0, minus 6, and 15. So this is your 3a square. Okay. And in the question, it is minus 3a square. When you substitute, you can put it as minus 3a square, or otherwise you can put it with minus 3a square. Okay. So when you multiply this minus inside, here it will be minus. This will become plus, minus. This will become minus, minus, minus. This will become plus. Okay. So for your minus 3a square, this is your value. A, we will write it down. Then your 9i. Your 9i is nothing but your identity matrix with 9. So it will be 9, 0, 0, 0, 9, 0, 0, 0, 9. Your identity matrix is nothing but 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, since it is 9i, I have multiplied into 9. Okay, so after writing all these things, what you have to do, you're going to substitute it in that equation. So that equation is a cube minus 3a square minus a plus 9i. I'm going to write it here itself. Here, then only you'll have space. So for your a cube, your value is 4 minus 9, 21, 11 minus 2, 11, 1 minus 7, 7. Okay, that is your a cube. Then minus 3a square. So since I have multiplied with minus, here I can put plus. Okay, plus your values are minus 12, 9, minus 18, minus 9, minus 6, minus 12, 0, 6, and minus 15. Okay, and then it is minus a. Your given matrix is A. You're going to multiply this minus inside. So I'll multiply that minus and I put plus here. So when I multiply minus, it will become minus 1, 0, minus 3, minus 2, minus 1, minus into minus plus 1, and then minus 1, plus 1, minus 1. Okay. So I multiplied that minus inside. Then plus 9i plus your 9i. So it will be 900, 090, 009. Okay. So that is your 9i. Now what you have to do? So this equation I have to write it again. Your a cube minus 3a square minus a plus 9i is equal to, so you will take 4 minus 12 minus 1 plus 9. What is it? So when you add it, 4 plus 9 is 13. Minus 12 minus 1 is also 13. So 13 minus 13 becomes 0. Okay, you can do the calculation. Okay, that is one step. If you don't want to do the steps, you can just do it like this. So minus 9 plus 9, it becomes 0. Here it is 0. So it will become 0. 21 minus 18 minus 3 and 0. So minus 18 minus 3 will become minus 21. So 21 minus 21, 0. You should definitely get 0. Okay. Next, 11 minus 9 minus 2 and 0. So minus 9 and minus 2 will become minus 11. 11 minus 11. 0. Like that for all the terms, check check, and it has to be equal to 0. Check it, don't do it directly. You check it and see whether it is equal to 0. If at all you've gone wrong in finding out the values in some place, you won't make it equal to 0. Okay, so concentrate in whatever you're doing. When you're finding out your a square and your a cube, be very careful. See? Immediately you can write your Cayley-Hamilton theorem is verified. The Cayley-Hamilton theorem is verified. So since it is verified, what is your next step? You can find out your A inverse and your A power 4. To find out your A inverse and your A power 4, what you'll have to do, your first equation, for the first equation, you will multiply it into A inverse. Have you all finished writing?
Yes, ma'am.
You're not finished writing, right quickly. Anyone still writing? Okay. So after you finish writing, to find A inverse. Okay. To find A inverse, what you have to do? It is. You'll find out your A inverse. So what you have to do? You'll multiply your first equation by A inverse. Okay, your A inverse is nothing but 1 by A. Okay, 1 by A. So when you multiply it with A inverse, it becomes A square minus 3A minus A into 1 by A, it will become 1, which you will take it as your identity matrix. Okay, 1i, and this will become 9A inverse is equal to 0. Okay, in that you want only your A inverse, so it will be 9A inverse. You keep it this side, take all other term that side, so it will become minus A square plus 3A. This also will become plus I. Okay, you want only your A inverse. Your A inverse is equal to, you're able to see the board. So your A inverse will become, this 9 will go down, 1 by A into your minus A square plus 3A plus I. Okay, now you substitute your values. First you find out this value, then divide it by 9. Here one of you, for this 1 by 2, minus into minus 1, 2. This is the problem yesterday. Okay, yesterday I had this one. Okay, so here you have got minus 1 by 2. Already there's one minus. You have got, when you're taking this 1 by 2 inside, it becomes minus 1 by minus into divided by a minus. So this minus minus will get cancelled. Okay, this minus minus will get cancelled, and this will change to 1 by 2. The student who had gone wrong will understand why I'm telling this. Suddenly you got 5. Okay, 5, I don't know how you're getting that value. So when you have this minus sign, that negative sign will get cancelled and you will directly get 1 by 2 only. Okay, instead of doing all these things, just stop with keeping this this constant. Okay, 1 by 9, no. Like that for yesterday's problem, it was 1 by 2. Okay, keep that 1 by 2 outside itself. Don't take it inside. Then only you'll get so many confusions. Okay, so keep this 1 by 9 just like that and just find out this value. Okay, find out that value.
1 by 9
Right.
bracket 0
Tell me.
3 3
Wait,
1 by
1 by
9
9.
0
See, yeah,
3
0.
3
Hmm.
3 2
Then,
minus 7 3 2 minus 7 3
okay.
minus 1 minus 1.
Very good. Super. So anyone else got the same value? I will also check it with her. A inverse is equal to 0 3 3 3 2 minus 7 3 minus 1 minus 1. Very good. Super. Okay. Who was that actually? It was very good. Okay. Similarly, find out your a power 4. So how he got this value is, he has found out this equation, that is your minus a square plus 3a plus I. Okay, you'll find out that value. Put this 1 by 9 outside itself. Don't take it inside. When you take it inside, you're getting so much of confusion. I really don't know why. Okay, so what you do, you just put this 1 by 9 outside itself. You need not take it inside. So this is your A inverse. Very good. Similarly, find out your A power 4. How do you find out your A power 4? To find your A power
Multiply
4,
into A equation.
very good. You have to multiply your first equation by A. Okay, you will multiply it by A. So when you multiply it with A, you have A power 4 minus 3A cube minus A square plus 9A equal to 0. In this, you need only your A power 4. You want to find out your value for A power 4. So A power 4 is equal to 3A cube plus A square minus 9A. Okay, you know the values of your A cube, A square, and your given matrix. Okay, so add it and tell me the value of your A power.